Okay, Everett. You are one tough customer, dude, okay? Not only, okay, do you want a plausible definition of free will, not only do you want to know a plausible mechanism that this could be, not only do you want me to prove that the world might be non-deterministic, right, okay, you actually have two more criteria for me here. Okay. Let's go over to your chalkboard this time, and I'll diagram it out for you. This is the closest style I could get to your blackboard, Everett. So I'm going to go with it. Okay, let's briefly review exactly how this non-deterministic neuron works. Actually, I've never really gone into depth as to what you should expect from this neuron. So let me just take this opportunity to talk about it a little bit here. Okay. So, of course, in vivo, in the living brain, the neuron's going to be connected. It's going to be connected to previous neurons through its dendrites, and then it's going to be connected to the next neurons in the chain by its axon, right? But we're taking this neuron out of the brain right now, and we're bringing it into the lab using it for our own nefarious purposes. Okay, so what we're going to do is we're going to isolate this neuron. And then we're going to cut along the dotted lines here and take out a section of the neuron's membrane here, right along the axon, okay? And so we're going to chop it off like this, and we're left with the central segment here, right? And this is just like a round tube of neuronal membrane, which is described by the Hodgkin-Huxley equation. All right. So the first thing we're going to do is we're going to attach to the outside of it an electrode, and we're going to ground it. So the outside of the neuron is going to be connected to our reference voltage at 0 volts. And then we're going to very carefully take a fine wire and insert it into the axon tube here, right? So basically, we've got the outside of the neuron is grounded, and we've got a little probe on the inside that is going to be able. We're going to be able to measure the voltage of this neuron with, right? Okay, so we're going to connect one end of this probe to a switch, so we can ground the inside of the neuron too, and we're going to connect the other side of this probe to a voltmeter, so we can measure the voltage which is across the neuron's membrane. Okay, so that's our experimental setup here, right? And so the first thing we do is sometime before t equals 0, we close the switch, right? So our neuron is grounded. The voltage on the inside and the outside are 0. And we kind of let the neuron, we let the transient processes die away. We let the neuron reach, equilibrium with itself, right? So the neuron is kind of reset here to 0, all right? And then what we do is time t equals 0, we throw open the switch. And the question is, what does the voltage do after we've thrown open the switch? Now, since we're no longer grounding the inside of it, the neuron is free to assume any voltage that it likes here. But what exactly is the behavior of this neuron as described by the equation? Well, let me graph it out for you here on the graph paper. So remember, sometime before t equals 0, we close the switch. We let the neuron kind of like cook there for a while. And it's 0 volts until time t equals 0, and we fling open the switch, right? And then what happens next is actually non-deterministic. Okay, according to the equation which I claim this neuron behaves, the neuron can just stay at 0 volts for basically as long as it wants to. I mean, there's nothing that will cause it to move away from 0 volts. But at any time, t equals t0, so let t0 equals the time where it starts to fire off, it can just start ramping up in voltage. And it will ramp up until it reaches about 1 millivolt and saturate out. So that's basically the score here. I mean, this time interval here is non-deterministic. It can stay 0. I mean, there's just nothing that will cause it to stay 0. There's nothing that will cause it to get up. Any of these things is a perfectly good. I mean, it's just basically like if the universe were a book, the chapter about this neuron just wouldn't be written until the neuron actually does what it's going to do. That's just as simple as that. So your conditions on a solution here seem to be the following, okay? That the self is the cause of the first event leading to the decision, all right, and the conscious event of the election, I use a choice, but I say election, must be the product of neurons firing, okay, and you claim these are two contradictory things. They lead to infinite regress, okay? Now, let's take a closer look at this now, okay? My claim. My claim is my theory satisfies all of these desiderata. Furthermore, I posited a plausible mechanism for this, my non-deterministic neuron, right? So let's just mark out here and see how it could work here, right? Okay, so first of all, back to my most beloved example, right? I've got 2 kids, 1 pie. How am I going to make both of the kids happy? All right, so my desires and my intentions normatively constrain my elections at this point. What this means is there are inevitably many, many possible alternatives to satisfy my desires and satisfy the kids' desires. I'm just going to put 4 of them here to represent all of them, but there's thousands of them, right? I could bribe them off. I could say, you know, you don't get any pie, but here's $5, go away. Or I could go out and find an ice cream cone and give one kid an ice cream cone and one kid a pie. Or I could cut the pie in half vertically or horizontally, right? There's always many possible alternatives. Okay, now how do we elect among these guys, right? Well, here's what I propose, right? So here's my non-deterministic neuron. And here is time as t less than 0, right? So what happens is I'm faced with this, my kids come to me and now it's t less than 0, right? So what happens is the previous neuron resets this neuron to 0 volts, right? And we see what happens, right? It's going to stay, as long as this previous neuron is firing, it's going to stay at 0 volts. Now, at time t equals 0, when it comes time to make my election, the previous neuron releases it. Okay, so now my non-deterministic neuron is sitting here, and it can fire at any time non-deterministically from here, all right? So, what I'm going to do is I'm going to, you know, it can just fire anywhere in here, right? So what I'm going to do is I'm going to say if it fires in this interval, then what I'm going to do is I'm going to go get the kids an ice cream cone and a pie. If the neuron fires in this interval, I am going to go cut the pie in half horizontally. If it fires in this interval, I'm going to cut the pie in half vertically. If it fires in this interval, I'm going to bribe them. And if it hasn't fired yet, I'm going to reset it and start all over again. And just loop until it fires, right? And the next neuron in the chain here is going to time and see how long it takes this guy to fire. Now, this is actually biologically plausible. Okay, it is hypothesized now that the time distance between the spikings of the neuron is how the neurons encode their information. I can give you some references if you want. Okay, so let's fire this off, see how it goes. Am I going to choose this one? Am I going to fire in this range? Nope. Am I going to fire in this range? Nope. Am I going to fire in this range? Ding, 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 ding. Yep. So that's how I make my election. And it tells the next neuron detects that this is the one to do, and the rest is hand-waving as to how this thing actually happens. All right? Now, does this scenario satisfy your desiderata, right? Okay, so number 1. The self is the cause of the first event leading to the decision. I claim this is satisfied because what happens is at time t less than 0, the previous neuron resets this neuron to 0 volts. All right? That is the cause of the first event leading to this decision. All right? Now your second one is the conscious event of the election must be the product of the neurons firing. Well, a non-deterministic amount of time happens. Okay, there's no physical cause for when this guy is going to start to come. The story is completely incomplete, but sure enough, the neuron fires and I do my election. So I satisfied your second one. All right? Okay, Everett. I hope this satisfies you. If it doesn't satisfy you, I'll try again. Just give me another list of demands, and I'll see what I could do to release the hostages. Okay, but I have a few minutes left over after this, so I'm going to take this opportunity to give you a small sermon here, okay? All right, I am 40 years old. You are 20 years old, right? Okay, now, dude, the purpose of 20-year-olds on this planet is not to tell this group of 40-year-olds that they should be thinking like this group of 60-year-olds, okay? The purpose of 20-year-olds is to think of something which no 40-year-old could possibly even dream of, okay? You are the future, man. Your generation is what we look to for the new and creative ideas. But it's not going to happen if you keep trapped in this mindset. None of this math, you're studying to be a chemical engineer, man. Okay, you've got to know 10 times as much about solving differential equations as I do, and probably 1,000 times what I know about ion transport, for heaven's sakes. You could have done this, okay? The only reason that you didn't do this is because you weren't looking for it. You had this preconceived notion that free will was impossible. Dude, free your mind, man. Do you think that's air you're breathing? Okay? It's like, come up with some creative ideas, man. It's like, okay, enough of the sermon anyways. I hope this convinced you. If it doesn't, I'll take another shot at it.